All right, so we're on lesson 6.1, properties of square roots, and the big ideas are the following. So number one, a square root, which we also call a radical, and it looks like this. This is the symbol for square root. That symbol is the inverse of a squaring. Okay, so what does that mean? That means for you want to think about what it means to be squaring a number. So for instance, if I write 4 squared, we are squaring the 4. That means we're multiplying it by itself. And that gives us the number 16. When if I want to do the inverse of that, I'm going to square root it, and it will give me back the original number of 4. So if I take the square root of 16, I'm taking the square root of 4 squared. So I'm asking the number, what number do I multiply by itself to get 16? And that number would be 4. In terms of the symbol, we think of these inverses of canceling each other. So the square and the square root undo each other, leaving us with just the number, and the radical goes away. But we can only do that if the number has a square on it. All right. And then 2 more ideas. One is called the product rule. Which says that if I have the square root of a product, so I'm multiplying x times y here, I can break that up into 2 radicals, separate them. So that's the square root of x times the square root of y. I also have a quotient rule. And that is if I take the square root of a quotient, like x divided by y, I can break that up into 2 radicals as well. I can square root the numerator and I can square root the denominator separate from each other. We do not have a rule for adding and subtracting, however, so I just want to stipulate, if you have under the radical a sum of 2 numbers like a plus b, that is not equal to, that does not equal square root of a plus the square root of b. You can't do this. This is a do not do. That's breaking the laws. All right, so you can only break up the radical if you're multiplying 2 numbers under the radical or if you're dividing. Okay, so just keep those straight. And let's do some practice together. Okay, so a few examples. All right, so again, if I want to simplify a radical, I need to get a perfect square. So what I'm going to do is whatever number I get, I'm going to factor it and look for perfect squares. That's my strategy. All right, so example number 1. Let's take a look at square root of 150. All right, well, of itself, right now, there doesn't look like there's any perfect squares, so we'll need to do a factorization. So you remember your old factor trees, I hope. I'm going to break that up. All right, well, it ends in a 0, so I know that 10 multiplies it, 10 times 15. And then break the 10 down, 2 times 5. And break 15 down, that's 3 times 5. And now I see 2 matching factors, the 5s. So what I'm going to do is regroup those together. That's 5 times 5, or 5 squared. And the 2 and the 3 have no matching factors, so I'll keep those separate from the 5 squared. That will look like this. Square root of 5 times 5, 5 squared, and then 2 times 3, times 2, times 3. Everything's under the radical still. All right, let's simplify this now. Now I can use my product rule up here that says that I can break up that factored form into 2 separate radicals. So that gives me square root of 5 squared times square root. And I'm going to keep the 2 and the 3 together since I can't take the square root of those. I'm just going to keep those together. And now I can simplify the left radical. The square root symbol will cancel with the power of 2, and it leaves what's inside. Just the 5 comes out. And so we're left with 5 there. These do not have squares on them, so they stay inside. So let's multiply them together to get 6. This expression is called 5 radical 6 or 5 root 6. This is a product of two numbers. One is an outside number, that's the 5. 6 is inside. We can't combine those to get 30. So this is the simplified form. Let's try another one. So how about we do a quotient? All right, so how about square root of the fraction 15 over 64? All right, well, once again, I'm going to use a quotient rule and break this into 2 radicals. And then I try to simplify each. So I'm going to look at the factors of 15 and the factors of 64. So 15 is easy. That's 3 times 5. And those are prime, can't go any further. So I can't take the square root of any of those. So this numerator will not be simplified. Let's look at 64. All right, so if you need to break it down into multiple factors, fine, but I do remember it's 8 times 8. All right, so I can rewrite this as 8 squared. So let's go back to our fraction. The numerator is going to stay square root of 15. The bottom denominator is square root of 8 squared. And then we're going to cancel the square and the radical, and that leaves us with just the 8 in the denominator. And so this simplifies to square root of 15 divided by 8. All right, let's try a couple more. How about a sum? In the numerator, I'm adding two numbers together. One is in a radical, one is not, but both are being divided by 2. So first off, I'm going to use the rule of fractions that I'm going to split this into 2 fractions, 6 over 2 plus square root of 8 over 2. Now I could simplify 6 over 2, but I can divide these because neither have a radical, but I can't divide 8 by 2 because the 8 is inside the radical and the 2 is not. So I need to treat these separately. I'm going to look at square root of 8 and rewrite that. Square root of 8. So start with 8, break it up into its factors. 2 times 4. And 4 can be rewritten as 2 squared. So there's my perfect square. And so when I take square root of 8, that's equal to, this number doesn't have a perfect square, so it stays inside the radical. This one I'll be able to simplify, crossing out the radical and the 2, leaving the 2 that's inside. That's all that's left, so I'm left with 2 times the square root of 2. All right, so let's go back up to our fraction. So this was like our side work. So this is equal to 6 divided by 2. That's 3 plus. I'm going to replace radical 8 with 2 radical 2. And we're dividing by 2. On this fraction, I have 2 outside numbers and an inside number. Again, if it's inside the radical, it can't be reduced or combined with any other number unless that number is inside a radical as well. So all I can do is reduce the outside numbers. 2 divided by 2 is 1. And so this all simplifies to 3 plus the square root of 2. All right, I'll give you one more example. What if I have negative square root of 80? All right, this negative in front, remember that it just means that you're multiplying by -1. Okay, so that's going to be on my next line. I'm going to have a -1 there, multiplying. But let's break down the 80. So 80. Well, that's 8 times 10, right? Break down the 8. 8 is 4 times 2. And 10 is 2 times 5. So right away I see a perfect square right there. But 4 breaks down even more. That's 2 times 2 again. So I have 2 times 2 times 2 times 2 times 5. So I have 2 squares there. So let's write this out here. I have 2 squared times, again, there I go, sorry about that. Again, so let me just, since you didn't see that on the screen, I broke 80 down, 8 times 10. I broke the 8 down to 4 times 2, and the 10 down to 2 times 5. And then the 4 I broke down again as another factor of 2 times 2. So I have 2 times 2 times 2 times 2 times 5. All right, just grouping these pairs together, perfect squares. All right, so I have my negative times the radical, 2 squared times 2 squared times 5. On to the radical. All right, we can break this into 3 separate radicals, but I'm just going to write it as a shortcut. I'm just going to cancel any perfect squares, come out, so the 2's coming out. Don't forget there's a negative in front, so the 2 comes out. All right, another perfect square cancels with the radical, so this 2 comes out. So this is not 22, it's 2 times 2. This 5 does not have a perfect square, so it does not come out, but we are going to multiply by that radical of the remaining factors, square root of 5. And almost done, we just multiply these outside numbers together, so that's -4 radical 5. All right, couple things to let you know that if you're simplifying, if you're doing some work and you end up with a negative inside the radical, so if I have the square root of -3, for instance, we cannot take the square root of a negative number. Okay, we would say this number does not exist. All right, and one more thing, you'll be asked to evaluate a radical. So an example of that would be evaluate the square root of b squared minus 4ac when, let's say, a equals 2, b equals -8, and c equals -4. All right, so that just means we have to plug in those numbers into this radical. So square root b squared first, so we're going to take -8 and square it, and since it has a negative, I want to make sure I put that in parentheses. I'm squaring the negative as much as I'm squaring the 8. All right, next we're going to subtract 4 times a times c. So -4, and where the a and the c are, again, parentheses to show the multiplication, a, and which is 2 in the first parentheses, and -4 in the second. And now we apply order of operations. Order of operations says go inside the grouping symbol, which is the radical right now. So we're going to go inside. Inside it sees squaring, subtraction, and multiplication. In order of operations, we square first. So that's the square root, stays there. Grouping symbol stays there. We're going to get negative 8 times negative 8, which is positive 64. All right, here we're going to subtract, but we'll save that to the end. Multiply these three numbers together. That's 4 times 2 times negative 4. All right, well that's 8 times negative 4, and that is negative 32. So all of these, the product of three numbers is negative 32. All right, double negative, so I can rewrite that as a sum, square root of 64 plus 32, and I add those together, and I get square root of 96. Now, question is can I simplify that? So we need factors of 96. So 96, that's divisible by 2. 2 times 48. And 48 is 6 times 8, 4 times 12, lots of ways to do that one. Okay, 4 is 2 times 2, and 12 is 6 times 2, and 6 is 2 times 3. Running out of paper. All right, so 96, let's see, all the perfect squares we group together. Here's a perfect square, 2 squared. Here's another perfect square, 2 times 2 here. Now that's a total of 4 2's right now, so let me circle those. I do still see a 2 and a 3. There's no pairs to match it up with, so it's 2 times 3. All right, so we're going to take the square root of that number. That means we're going to square root this, perfect squares come out, and so that gives us square root of 2 squared, cancel that. We have 2 on the outside. Another factor of 2 comes out from the square root. And the 2 and the 3 don't match, so those go together and stay inside. And what does this simplify to? 2 times 2 on the outside, 2 times 3 on the inside, so 4 square root of 6. And that's our final answer. All right, it is time for you to go to the practice for 6.1 and make sure if you don't understand any of these that you come and get some help.